Namaskar, I am Anand and you are watching Join for Education. Today I am going to solve the questions of exercise 15.1 of class 9 subject mathematics. Let's start the solution. Question number 1. In a cricket match, a batsman hits a boundary 6 times out of 30 balls she plays. Find the probability that she did not hit a boundary. From question it is clear that the total number of balls played by the batsman or batswoman equal to 30. Boundary hit 6. So number of balls in which he did not hit any boundary equal to 30 minus 6 equal to 24. So the favorable outcomes of this experiment is 24 and total outcomes of this experiment is 30. And we know that the probability of the event equal to number of favorable outcomes by total number of outcomes. So the probability that she did not hit a boundary equal to number of balls in which she did not hit any boundary by total number of balls played. So 24 by 30 equal to 4 by 5. So this one is cancelled out. 6 4 ja 24, 6 5 ja 35. So the exact answer is 4 by 5. Of that there is no problem to understand the explanation of this solution. Let's see question number 2. 1500 families with 2 children were selected randomly and the following data were recorded. Number of girls in a family, 2 girls in 475 families, 1 girl in 814 families, and 0 girls in 211 families. In this question, ask us compute the probability of a family chosen at random having 2 girls, 1 girl, and no girls. Also check whether the sum of these probability is 1. So the probability of a family having 2 girls equal to number of families having 2 girls. From the data it is clear that this is 475 and total number of families is 1500. So favorable outcomes is 475 and total outcomes is 1500 after the cancellation or cancelled out of the common factor we get here 19 by 60. So the answer of this one is 19 by 60. Similarly, probability of a family having 1 girl equal to number of favorable outcomes will be 814 and total numbers of outcome will be 1500. After the cancelled out of the common factor we get this one. So the answer of the question number 2 will be 407 by 750. Probability of a family having no girl equal to total number of favorable outcomes will be 211 and total number of outcomes is 1500. After the cancelled out or there is no any common factor, so the probability of a family chosen at random having no girl will be 211 by 1500. According to the question, we add all the probabilities, then we get here 1. Let's see question number 3. This is the question number 3. In a particular section of class 9, 40 students were asked about the months of their birth, and the following graph was prepared for the data so obtained. Find the probability that a student of the class was born in August. Let's see. This is the graph. So in January, number of students 3, February, number of students 4, and so on. In August, number of students 6. So let's see here. Total number of students considered is 40. Number of students born in August is 6. See here, this is the 6. So probability of the student was born in August is number of students born in August by total number of students considered. So the favorable outcomes or number of favorable outcomes is 6, and total number of outcomes of this experiment is 40. After the cancelled out of the common factor, we have 3 by 20. So 3 by 20 is the answer of this question. Let's see question number 4. 3 coins are tossed simultaneously 200 times with the following frequency of different outcomes. 3 heads 23, 2 heads 72, 1 head 77, and no head 28. If the 3 coins are simultaneously tossed again, compute the probability of 2 heads coming up. So the total number of tosses or total number of outcomes is 200. Number of times 2 heads occurred according to the data, this is 72. This is the number of favorable outcomes. So the probability of 2 heads coming up equal to number of times 2 heads occurred or number of favorable outcomes by total number of outcomes of the experiment. So this is the 72 by 200. After the cancelled out of the common factor, we have 9 by 25. So this is the answer of the question number 4. Let's see question number 5. An organization selected 2,400 families at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. The information gathered is listed in the table below. Monthly income in rupees less than 7,000, vehicle per family 0 family 10, 1, 160, 0 vehicle 10 families, 1 vehicles 160 families, and 2 25, and above 2 0. Similarly 7,000 to 10,000, 1, 10, 100,000, 10,000, this data, and so on. 16,000 or more, 0 vehicles 1 family, 1 vehicles 579 family, 2 vehicles 82 family, above 2 vehicles 88 family. Suppose a family is chosen, find the probability that the family chosen is earning rupees 10,000 to 1,000, 13,000 per month and owning exactly 2 vehicles. So for question number 1, we consider about this one. So ask us exactly 2 vehicles. So exactly 2 vehicles is 29 family. So the number of favorable outcomes will be 29, and total outcomes will be 2,400. So here will be answer of the question will be probability of a family earning 10,000 to 13,000 per month and owning exactly two vehicles equal to number of families earning 10,000 to 13,000 per month and owning two vehicles is 29 according to the data. And total number of families, this is the total number of outcome of this experiment is 2400. There is no any common factor to cancel out. So the answer will be 29 by 2400. Similarly, the probability of a family earning rupees 16,000 or more per month and owning exactly one vehicle. So owning it is will be 0. So here will be number of families earning 60,000 or more and owning one vehicle. It means that this is the one vehicle and this is 579. So this is the 579 by 2400. After the cancel out of the common factor, the answer of this question is 193 by 800. Similarly, probability of a family earning less than 7,000 per month and does not own any vehicle. It means that zero vehicle. So the number of zero vehicle less than 7,000, zero vehicle is the 10. So the data will be here in this way, 10 by 2400. After the cancelled out of the common factor, we have this one. So the answer of the question number 3 will be 1 by 240. Similarly, for question number 4, probability of a family earning 13,000 to 16,000 per month and owning more than two vehicles. 13,000 to 16,000, this is the 13,000 to 16,000 and owning two vehicles. So two vehicles, here is the two vehicles and it will be 59. So we have written here number of families 13,000 per month and owning two vehicles is above two vehicles is 25. More than two vehicles. So more than two vehicles is means the above two vehicles is 25. So here will be 25 by 2400. After the cancelled out of the common factor, 1 by 96. Question number 5 of this section, probability of a family owning zero vehicles or one vehicles equal to probability of a family not owning more than one vehicles will be this one, V8, and this one by this one. After the cancel out of the common factor, we have this one. Let's see question number 6. Following tables show the performance of two sections of students in mathematics test of 100 marks, 0 to 27 and so on. In this question, ask us find the probability that a student obtained less than 20% in mathematics test. Find the probability that a student obtained marks 60 or above. Total number of a student is 90. Probability of a student obtained less than 20% mark equal to number of a student who obtained less than 20% and total number of a student. So number of a student who obtained less than 20% is 7 and total number of a student is 90. So this is the answer of the first part of the question number 6. Similarly, probability of a student obtained 60 marks or above equal to number of a student who obtained 60 marks or more is 15 plus 8 by 90 equal to 23 by 90. Of that there is no problem to understand. the solution of the question number 1 and 2 of the main question 6. Let's see question number 7. To know the opinion of the student about the subject statistics, a survey of 200 students was conducted. The data is recorded in the following table. Like 135, dislike 65. Find the probability that a student chosen at random. Like statistics, probability of the students like statistics is number of students who like statistics by total number of students equal to 135 by 200. After the cancel out of the common factor, this one will be 27 by 40. So the answer of the first part of this question is 27 by 40. Hope that there is no problem to understand the explanation of this solution. Similarly, probability of the student doesn't like statistics is the number of students who do not like statistics and number of students according to data. This is the 65 by 200. After the cancel out of the common factor, this one will be 13 by 40. So the answer of the second part of the question number 7 is 13 by 40. Hope that there is no problem to understand the explanation of the solution of this question. Let's see question number 8. The distance in kilometer of 40 engineers from their residence to their place of work were found as follows. What is the empirical probability that an engineer lives less than 7 km from the place of work, more than or equal to 7 km from the her place of work, within half kilometer from her place of work? Total number of engineers is 40. Let us arrange the data in ascending order as follows. P, an engineer lives less than 7 km from her place of work, will be 9. And total number of engineers is 40. So the answer of the first part of the question number 8 is 9 by 40. Hope that there is no problem to understand the explanation of this solution. Similarly, an probability of an engineer lives more than or equal to 7 km from her workplace equal to number of engineers who lives more than or equal to 7 km from their workplace by total numbers of engineers equal to, from the data it is clear that 31 by 40. There is no any common factor to cancel out, so the answer will be 31 by 40. P, or probability of an engineer lives within half kilometer from her place. So the number of this one is 20, or favorable number of favorable outcomes is 0, and the number of total outcomes is 40. So here will be 0. So these are the answer of the 1, 2, 3 of question number 8. Question number 9 and 10 are activities, so a student should perform these activities on their own. This is the question number 11. 11 bags of wheat flour, each mark 5 kg actually of content the following weights of flour in kg. Weights are given here. Find the probability that any of these bags chosen at random contains more than 5 kg of flour. Total number of bags is 11. So the total number of outcomes is 11. Probability a bag weighing more than 5 kg. So the number of favorable outcomes will be 7. And total number of outcome is 11. There is no any common factor between 7 and 11. So the answer of this question will be 7 by 11. Let's see question number 12. A study was conducted to find out the concentration of sulfur dioxide in the air parts per million ppm of a certain city. The data obtained for 30 days is as follows. Using this table, find the probability that the concentration of sulfur dioxide in the interval 0.12 to 0.16 on any these days. Total number of days is 30. Probability of the concentration of the sulfur dioxide in the interval 0.12 to 0.16 in a day. So the number of favorable outcome is here 2 and total number of outcome is 30. We cancelled out the common factor and we get 1 by 15. So 1 by 15 is the answer of this question. Hope that there is no problem to understand the solution of this question. Let's see question number 13. The blood group of 30 students of class 8 are recorded as follows. Use this table to determine probability that a student of this class selected at random blood group AB. Total number of students is 30. So the total number of outcomes is 30. And the probability of a student has blood group AB. So the total number of favorable outcomes is 3. So number of students which have the blood group AB by number of or total number of students. After the cancelled out of the common factor, we get 1 by 10. So 1 by 10 is the answer of this question. Hope that there is no problem to understand the explanation of solution of this question. So in this exercise we have 13 questions and I have done all of these 13 questions. Hope that this solution will be useful to the students who are studying in class 9. If you think that this solution is useful to the other students, then please do circulate this video lecture or this video solution to other students of your surrounding. Thank you very much to stay with me till the solution of the question number 13. And question number 13 is the last question of this exercise. So see question number 13. This is the question number 12, 11, 9 and 10. Student will do himself or herself because this question 9 and 10 are based on the activities. Question number 8 and question number 7, question number 6, question number 5 and 4, question number 1 to 3. So all of the questions I have solved of this exercise 15.1. So all of the questions based on the basic concept. If we do an experiment, then we get total number of outcomes. If we consider about a event, then the number of outcomes which is related to the event is known as the number of favorable outcomes. So the probability of an event equal to number of favorable outcomes by total number of outcomes. So this is the basic formula of the probability. Probability of an event is greater than or equal to 0 but less than or equal to 1. So this is the basic concept of probability according to the standard of class 9. Thank you very much to stay with me till the last step solution of question number 13 of this exercise. If once again I requested to all of you, if you think that this is useful to the student of class 9, then please do circulate this video lecture or this solution to other students of your surrounding. Then my work will be effective. Once again I thanks to all of you. Thank you very much.